How much Wi-Fi signal strength do I lose per foot of antenna cable? I'm thinking of buying an antenna for a router so I can extend my Wi-Fi. I have seen a few products like TP-Link TL and 2405C indoor desktop omnidirectional antenna. The length of the wire is 130 and NBSP cm. Is it okay if I increase the length of the wire, or will it affect the performance of the router? What is the maximum cm of length that I can increase?
There is no arbitrary limit. Any increase in cable length will reduce signal strength. So will the connectors that you'll need to connect another length of cable to this one. As Borgie and David Posthill said in the comments, how much it's reduced for a given length depends on the cable and the frequency. A common relatively inexpensive cable for short runs of Wi-Fi antennas is LMR 100. At 2.4 GHz, the common Wi-Fi band, 15 feet of LMR 100 will result in signal loss of about 6 dB. That's equivalent to dropping power to just 25% of what it was. Each 3 dB equals 50% gain or loss in power. With LMR 400 cable, your loss would be only about 1 dB. But that cable is more expensive, and also a lot less flexible equals more difficult to install. The loss in dB is linear with the cable length. So if you use 30 feet of LMR 100 cable, your loss will be 12 dB, i.e. your signal is now about 1/16 the power that it was. With 7.5 feet, loss will be only 3 dB, you lose half of your signal. All of the above numbers are for the 2.4 GHz Wi-Fi band. For 5 GHz it will be much worse. Don't even think about using RG59, the older, thinner coax that used to be used for TV cable and antennas and commonly is seen with F or BNC connectors attached. It's not even the right impedance, or RG58, the right impedance, but still very lossy at these frequencies. These cable types aren't rated at all for use above 1 GHz. You can find data sheets with signal loss graphs and calculators for various types of microwave coax all over the web. Here's a calculator found at a cable dealer that covers a wide variety of cable types. And to convert dB to ratios, or back, try this. Note, since this is signal loss we're talking about, enter the dB number as a negative number before pressing calculate. Note also that you want the power ratio, not voltage. One last tip, don't try to assemble cables yourself. Buy cables with the right connectors already attached. Very minor seeming mistakes with connector assembly can cause huge losses at these frequencies. And absolutely do not cut the connectors off and try to splice the coax. Might as well throw the antenna away at that point.
The short answer is, ideally you would have no cable. Every bit degrades the signal. You get about 10 meters of cable before you need some kind of amplifier / booster / repeater, otherwise your signal's about as good as dead.
When you're trying to get actual practical information about the product, first step is to take a look at the product datasheet. So on TP-Link's downloads website for linked product, you'll be able to download the datasheet. When you do, you'll be able to find the exact cable type used there. In this case, it's RG174. Unfortunately, they did not specify exact manufacturer of the cable, so we need to go and look for some generic answers. Usually, losses are specified either per meter or per 100 feet and are frequency dependent, so let's see if we can try that for this cable. Go to Google, type RG174 coaxial cable losses 2.4 GHz. One of the results is this handy table. Looking there, you can find that RG174 has around 1.7 dB attenuation per 1 meter, giving around 2.2 dB loss for the 1.3 meters piece that comes with the antenna. Do keep in mind that the numbers are not for the specific cable you have, but for category, so don't be surprised if you find slightly different values elsewhere.
A much better idea is to move the router to a much higher location by extending the hard wiring and power, then you still get maximum power to the aerial and little noticeable loss on Ethernet cable.
If you want to support the channel, please consider subscribing.